Alright, day 6. This is the lesson where we learn about slant asymptotes and holes in our rational functions, which we are still graphing. Here's the key, people. Let's review the rules for asymptotes and then just add the one extra rule to it. No big deal, right? To find the vertical asymptote, or asymptotes, we would set the denominator equal to 0 and solve. To find the horizontal asymptotes, that's where we have to consider the degree. If the numerator degree is less than the denominator, the asymptote is y equals 0. If the numerator degree is equal, then we make a little fraction out of the leading coefficients, and that's the asymptote. Okay. Oh, sorry for the yawn. It's not even that late. If the degree of the numerator is greater than the denominator, then there is no horizontal asymptote. However, there might be a slant asymptote. If the degree of the numerator is 1 greater than the degree of the denominator, there's a slant asymptote, which will be the quotient that you get when the numerator is divided by the denominator. You can ignore the remainder. You understand what an asymptote is. This dashed green line would be an asymptote if we had a function that was getting closer and closer and closer to it, but never touching. And so far we've seen horizontal asymptotes and vertical asymptotes. But now, so when I say slant asymptote, I'm saying that you can have a function that's getting closer and closer and closer to a slanted line. Alright, so you can have asymptotes that go at a diagonal, and they're called slant asymptotes. Now, when we had horizontal, let me scroll up for a second. When we had horizontal asymptotes, okay, that's a horrible horizontal line, whatever. Horizontal lines had equations like y equals 0 if it was at the x-axis, or y equals 5. Horizontal lines all have the equation y equals something. Vertical lines had equations, man, I cannot draw a vertical, I'm just going to cheat. Vertical line. Okay, there you go. Vertical lines had equations x equals something, like x equals 3 or x equals -2 or whatever. Alright, now, please remember that in general, slanted lines are going to have equations of the form y equals mx plus b. Okay, where you have a slope and a y-intercept. So, yeah, that's right. Get all that y equals mx plus b stuff back in the front of your brain. Alright, but we'll cross that bridge when we come to it. Alright, so for these first several functions, we are simply supposed to determine the slant asymptote. Nothing else. So we can just focus on this new thing that we've learned. Alright, so first of all, notice that the degree of the numerator is 1 more than the denominator. The degree of the numerator is 2, the degree of the denominator is 1. So when the degree of the numerator is just 1 more, that's when you're going to have a slant asymptote. And we are supposed to find it by dividing. Alright, so we're dividing the numerator by the denominator. The idea is this. Alright, x minus 2, and we're dividing into x squared plus 7x minus 5. However, when you have a nice little binomial like this, a linear binomial, it's easiest to use synthetic division. Alright, so instead of trying to do long division, I'm going to do synthetic division. Look at these coefficients. We'll need the box, and the coefficients are 1, 7, and -5. Okay, are you with me? I think you're with me. I think we both know what's going to happen right now. So we had a -2, so this is going to be a +2 little box here. My daughter just colored her hair green, people. I mean, you know, it's not all green, but it's got the green like streaks in it. So on the one hand, it's Roswell colors. You know, that's my school for you internet people. But on the other hand, she goes to Northern High School, so she goes Centennial. On the other hand, it looks pretty cool, but you know, teenagers will be teenagers. And now my daughter has green hair. Alright, but that's fine. I can be a cool dad, I guess. Yeah, let's go with that. Anyway, that's what's happening in Burton World. Lost my train of thought. Okay, yeah, so the 1 comes down. 1 times 2 is 2, and that's 9. 9 times 2 is 18. Shabam. And that's going to be 13. Okay, so ignore the remainder. The quotient part, if I turn this back into a situation, is going to be x plus 9. Alright, so guess what? Y equals x plus 9 is the slant asymptote for this particular graph. Okay? Yeah, so I mean that's literally a diagonal line that has a y-intercept of 9 and it's going up 1 over 1. We'll worry about graphing later. Anyhoozle, it's just that easy. Take a look at number 2. Notice that the degree of the numerator is 1 more than the denominator. So you know a slant asymptote is coming your way. Again, we have a nice linear binomial, so this would be a good one to do synthetic division once again. X plus 4, you know, set that equal to 0 and you get negative 4. So like that's what you put in the little box for synthetic. Coefficients 2, 3, negative 1, sir. So you do a little of this, a little of that. That comes down. 2 times negative 4 is negative 8. That's negative 5. Multiply, you get positive 20. You get a 19, okay? Ignore that. If you put the variables back in, you get 2x minus 5. And that is the equation of the slant asymptote for number 2. Okay? Is it possible that it's this easy? Well, it was, but you cannot do synthetic division for a quadratic. It only works for linear. So for number 3, we're gonna have to break down and do some long division. Okay, so just stop crying. You know, grab a Kleenex, dry your eyes, and you know, you can do this. I believe in you. I believe you can fly. So you got x to the 3rd power plus 8x squared plus 5x plus 16. Yeah, I'd sing more of that song, but you know, if I sing too much, YouTube will flag me for copyright infringement. And then nobody can watch this video and learn some math. You know? Because I sound just like R. Kelly, don't I? Yeah. That's what's happening. So, it's time to multiply by some stuff. So we have our long division. 3, 2, 1, 0. Okay, nothing's missing. So remember, the way long division works, you look at these first 2 terms, and you ask yourself, this times what will give you this? And the answer is x. X squared times x will give me x to the 3rd power. And you really should line up your like terms, so put it over there. Once you have the thing that will give you the thing, do the distributive property with it. Take this and distribute. So x times x squared, of course, is going to give you x to the 3rd power. X times 5 is going to give you 5x. Whoa. X to the 3rd power. this 5x, gotta line up those like terms. Like I said, listen to me. 5x is gonna go over here. Okay. So I've got this so far. Alright, now I will subtract by changing the sign. So this will become minus and this will become minus. Alright, and then I combine like terms and keep going. So this doesn't have anything to combine with, so it just comes down 8x squared. These actually cancel. Okay, so poof, they're gone. And then I bring down this 16. So, so I got this plus 16 happening. Alright, and you can tell I only have this one more term left, so let's go ahead and do it. So, once again, I'm basically starting over at this point, and I'm asking myself, x squared times what will give me 8x squared? Well, that's not even very challenging. Alright, clearly it is 8. Alright, x squared times 8 is 8x squared. So we got it. Once you have that, go ahead and distribute with it. Okay, so 8 times x squared, of course, is 8x squared, because that's what we just said. 8 times 5 is 40. So I put down 40. Okay, and one more time I will change the signs to subtract. So minus and minus. So those cancel out. And this is going to give me like what? Negative 24. Alright, and that's the remainder. But this up here is the quotient that we need. Alright, so our slant asymptote, which is what we're trying to find, is y equals x plus 8. This is the slant asymptote for this graph. Okay. Alright, let's keep going. How about number 4? I love these ones that are linear binomials because for those we can use synthetic. Let's go synthetic. So x minus 2, if I set that equal to 0, I'd get positive 2. So that's what goes in the little box. Coefficients are 1, negative 4, and 3. This is how we do it. Bump, 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 bump. This is going to come down. 1 times 2 is 2. That makes negative 2. And that makes negative 4. And that's negative 1. Okay, so once again, ignore the remainder there. Ignore that. If I put my variable back in, this is going to be y equals x minus 2. And that is my slant asymptote. Okay, let's do one more. And maybe we'll take a pic of the graph too, since this is the last one. Let's see a slant asymptote in action. Okay. Lost my train of thought. Okay. Yeah, this is a linear binomial, so once again we can do synthetic. So if I set that equal to 0, that would give me 2. 2, 7, 8 are my coefficients. Okay. And here we go. We bring down that 2. 2 times 2 is 4. That's 11. 2 times 11 is 22. So that's 30. Alright, but what really matters is this part right here. Oh no, I meant to go for purple. So putting the variable back in, the slant asymptote would be y equals 2x plus 11. This is my slant asymptote. Okay, now let's take a look at the graph of this and see if we can see this slant asymptote in action. Alright, I'm just going to go ahead and type this equation into my TI-84 Plus Silver Edition, because that's what I happen to have here. So what's my equation again? So I've got 2x squared plus 7x plus 8. All right, how do I do this again? Second. Okay, so I've got 2x. No. All right, 2x squared plus 7x plus 8 over x minus 2. Okay, now remember, we're expecting to see a vertical asymptote at 2. Alright, because you get a vertical asymptote by setting the denominator equal to 0. Alright, and there should be no horizontal asymptote because the top degree is higher, but we are expecting to see a slant asymptote at 2x plus 11. Remember, this 2x plus 11 means, where's my pen? I lost my pen. That 2x plus 11 means that the 11 is the y-intercept, and then this is like up 2 over 1. Anyway, let's take a look. So I'm just going to hit graph. Okay, now there's probably another branch, but it's all the way up high because 11 is this is 10, and the y-intercept of our slant asymptote is way up here. So let's change the window. So I'm going to hit the window button, and I'm going to change the maximum y value to 20 and take another look. Okay, so there's one branch. Remember, we're expecting to have a vertical asymptote at 2. Still don't see anything. Let me change that window even more. Y max of 40. Okay, now we're starting to see it up there. Okay, so you see it's a very long slant asymptote. Oh, well, I mean, it's infinitely long, but if we, and you know, the asymptote doesn't show up on the graph, but you can imagine the diagonal line that's happening right here. All right, let me just zoom out and see what happens. Okay, so you can begin to see it. So you can see that this side is approaching some sort of a line, and this side is approaching a line, and guess what that line is? That's the line 2x plus 11. Alright, so that's your slant asymptote, guys. And that is enough for this video, ladies and gentlemen. Actually, no, wait. Let's do one more. Slant asymptote, one more time. Again, notice that the top degree is 1 higher, so you know there's going to be a slant asymptote. We must divide to find the slant asymptote. So long division is the only thing that's going to work here. So x squared plus 2x. Alright, and there's my 10x to the third power plus 27x squared plus 14x plus 5. So I ask myself, x squared times what is going to give me 10x to the third power? X squared times 10x will give me 10x to the third power. So notice how I line up my like terms. I put my 10x in the x column, and once I have that 10x, I do the distributive property with it. Alright, 10x times x squared, of course, is 10x to the third power, just like we wanted. 10x times 2x is 20x squared. Alright, you subtract by changing the sign. So this is going to become minus, and this will also become minus. Okay, so these will cancel out. 27 minus 20 is going to be 7x squared. and then I'll bring these down. So I'll have plus 14x plus 5. And then I begin again. And I ask myself, x squared times what will give me 7x squared? Clearly the answer to that question is 7. So I'll put my 7 in the constant position. And then I distribute. Alright, 7 times x squared, of course, is 7x squared. 7 times 2x is 14x. And then we subtract by changing the signs. So this will become minus, and this will become minus. Now these will both end up canceling out, and I will just wind up bringing down the 5 as a remainder. Alright, but what I want is the slant asymptote, and the slant asymptote is going to be this quotient ignoring the remainder. Okay, so my slant asymptote is y equals 10x plus 7. Alright, and that is how you find slant asymptote. And this really is the last problem for this video.